In part 1, we are given the equation of the curve C. This is y to the power of 3 plus xy minus x squared. This is equal to 1. And in order for us to work on the tangent that is parallel to the x-axis for this curve C, we need an equation for dy dx. So let's differentiate this with respect to x. So on the left-hand side, if we were to carry out an implicit differentiation for this, this is going to be 3y squared dy dx plus, doing a product rule for this, x, let it remain constant, differentiating y with respect to x, we will be getting a dy dx. Then plus, differentiating x is 1, so it will be 1 time of y. Then minus away 2x is equal to, differentiating 1 with respect to x, it is equal to 0. And now we have an equation that involves dy dx. And at the place where the tangent is parallel to the x-axis, that is when dy dx is equal to 0. So we are going to let dy dx here be equal to 0 for this equation. And what we will be getting is 3y squared multiplied by 0 plus x multiplied by 0 plus y minus 2x. This is equal to 0. So we're going to be getting an equation y is equal to 2x. That means for this curve, whenever y is equal to 2x, we are going to be getting dy dx to be equal to 0. So I'm going to find x coordinate of the points where the tangent is parallel to the x-axis by letting this be equation number 1. This is one relationship because that point must be lying on this curve, and that point must also satisfy this equation. That is when all the dy dx are equal to 0. So I'm going to substitute equation number 2 into equation number 1. So replacing all the y by 2x, I will have a 2x here to the power of 3 plus x. Replacing this y, I will have a 2x, then minus x squared. This is equal to 1. Here we have a 8x to the power of 3. Here we will have a 2x squared minus x squared. It will be plus x squared. 1, I'm going to shift it over to the left-hand side. So I have this to be equal to 0. And this is just a cubic polynomial. We can definitely press this into our graphing calculator to solve for it. So from our graphing calculator, we will get the x-coordinate of the point where it is, the curve is parallel to the x-axis, and x-coordinate is equal to 0.462. And in part 2, we are going to make use of the result that we have obtained from part 1. Differentiating this equation here with respect to x, we should be able to prove and show that the equation that involves d squared y dx squared is going to be this one. So let's give it a try. Let's differentiate this with respect to x. So on the left-hand side here, if I were to differentiate this term, we are going to make use of the product rule. So 3y squared remain constant. I'm going to differentiate this, which will give us d squared y dx squared. And plus, differentiating this now, this gives us 6y dy dx. So this will be one of the terms in my product rule multiplied by this term which remains constant. So it will still be dy dx. Plus another product rule here again, x remain constant, differentiating dy dx is d squared y dx squared. Plus differentiating x is 1, then multiply by dy dx. Then differentiating this, I will have another dy dx. Differentiating this, it is just going to be minus 2. Differentiating 0 is 0. And I'm going to group all the d squared y dx squared together. So here we have a 3y squared, and this is another term that has d squared y dx squared. So plus x, this multiplied by d squared y dx squared. So we are getting this already. And for this is going to be plus 6y. dy dx times dy dx is dy dx squared. So we have our second term here. And this plus this gives us a plus 2 times of dy dx. And then minus 2, this is equal to 0. We have exactly the equation that we are supposed to show. So we have finished this part of the question. Next, we are supposed to derive the Maclaurin series for y. And we are given this And we are given this because we are supposed to come up with a Maclaurin series for y all the way up to x to the power of 3 terms. So we do need d cubed y dx cubed. So I guess the question has been a little bit generous by giving us this instead of having us to differentiate this another time to get d cubed y dx cubed. So let's try to find parts of the coefficients of my Maclaurin's series. That will be by letting x to be equal to 0. So first, let's derive the value of y when x is equal to 0. Substituting into here, we will have a y to the power of 3 plus x is 0 times y minus x is 0 square. This is equal to 1. This means that y cubed is equal to 1, so y must be equal to 1 when x is equal to 0. Next, I'm going to work on dy dx equation. So this is going to be 3 times of y, which is 1. So 1 to the power of 2. dy dx is what I'm supposed to find. Then plus x. In this case here, x is 0. And dy dx again is what I'm supposed to find, which will not change anything because it's multiplied by 0. Plus y, which is 1. Minus 2 times of x, which is 0. And for this, if I were to make dy dx the subject, dy dx is going to be equal to minus 1 over 3. And next, I'm going to make use of this that we have shown. So it will be 3y, y is 1, square plus x, x is 0. Then d square y dx square, which is what I am supposed to be finding here. Then plus 6 times of y, which is 1. dy dx, which is minus 1 over 3. So we have this square plus 2 times of dy dx. So it is once again negative 1 over 3 minus 2 is equal to 0. If you were to make d square y dx square the subject, by making this a subject, you will get this to be equal to 2 over 3. And finally, we need d cubed y dx cubed when x is equal to 0. So this was given to me by the question. It is equal to 20 over 27. And now we are ready to form the Maclaurin's series of y all the way up to x to the power of 3 terms. So y will be equal to f0, that is y when x is equal to 0. So it is going to be 1 plus f prime 0. F prime 0 is this. So it is minus 1 over 3 multiplied by x. F prime prime 0, which is this, so 2 over 3 divided by 2 factorial of x squared. And finally, f prime 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 0, which is 20 over 27. This divided by 3 factorial, x to the power of 3, and it is an infinite series, so plus dot dot dot. And this is equal to 1 minus 1 over 3x plus, this is 1 over 3x squared. And this, if you were to evaluate, it is 10 over 81, x to the power of 3.